Okay, so we're gonna do, so the last example we're gonna do for this verifying absolution is the following. So if y of x equals c1 cosine of kx plus c2 sine of kx, what is the value of k so y of x satisfies second y prime plus 49y equals to 0, right? That's the problem. Okay, so basically what we need to do is compare the left hand side with the right hand side. Okay, so that's what I need. So let's start. So y of x is c1 cosine kx plus c2 sine kx, right? So y prime of x is what? So you guys tell me. Negative c1 sine kx, yeah.
Just k.
Times k, right?
Yeah. K squared on the second.
Plus what? C2 cosine kx times k. So then you got second y prime, and this is what?
Negative c1 cosine kx.
Right. So negative c1 cosine kx times k squared plus minus, yeah, minus c2 minus c2 sine kx times k squared. Okay, that's my second prime, right? Now my left hand side is minus 49y, right? So what is this? So minus 49 times y is c1 cosine kx plus c2 sine kx, right? So how can I make these two similar? I need this guy, second y prime, to look equals to this guy that is minus 49y. So any ideas? What could I do? So I factor k squared, right? So I factor k squared. So I get second y prime of x, k squared. You wanna get the minus 2? Let's get the minus 2. So if we get c1 cosine kx plus c2 sine kx, right? So any ideas? How can I make these two look the same? So what is this guy? You recognize this guy? That's y. Yeah, that's y. So I can make it second y prime of x equals minus k squared y. And on the other side I have, this is minus 49y. Any ideas? So basically, we what is our job? Our job is to find k, right? So we need to solve these guys. So I just for example, I can move one to the other side. So I got 49 minus k squared, and then factor y, right? Equals to 0. Okay. So what is the solution of this? 49 minus k squared times y equals to 0. What are the solutions for that? I have two possibilities. What are the solutions for that? There you go. So there is a very important in real numbers. That's why we work with real numbers. 1, 2, 3, square root of that. Because if you have a times b equals to 0, this implies a equals to 0 or b equals to 0. That's why we work with real numbers. If you work with matrices, if you have been, you know something of linear algebra, you have a times b equals to 0, doesn't mean it does not apply to this. Okay? And that's why it's a good reason in quantum mechanics they don't use real numbers. They prefer matrices. Okay, so this is a good property, but sometimes it's not a good property. But for now, this is a good property. So from this, I can say either 49 minus k squared equals to 0 or y equals to 0. So is y equals to 0 a good solution? Not really. Because, from the beginning, I could see that y is a solution of this because the second derivative of y is 0. If y is 0, second derivative of 0 is 0. 49 times 0 is 0. So 0 is always a solution of, well, not always, but if the for most equations it's always a solution. So that's nothing interesting. But this one is interesting. That will get 49 equals k. So I get k equals plus or minus 7. Excuse me? Oh yeah, thanks. So then you can use plus or minus 7 is really not going to make a difference because we don't know what is C1, we don't know what is C2. So either way, you put 7 or minus 7, turns out it's going to be the same thing because cosine of minus 7x is the same that cosine of 7x. But basically, we don't know anything about C1 of C2. So those constants are just like dummy constants. Okay? So that's the one I wanted to solve. So we can now stop the video.